Okay. All right. I see that there are people here that aren't even on the list, like Brian. You're not on the list that Lisa gave me, but we're glad to have you here. Richard, I see you're on my list.
I'm on an
Um,
email at least.
yeah. Good. Okay, that's good. And Ben, I think that you're an intern. We're sort of working our way. If you want to go next,
Sure.
I would love to hear.
So I'm a mechanical engineering intern working in R&D, so research and development, focusing a lot on advanced development of technology for the company. Like Erin, I started in January, and I'm also a senior, and I go to Rensselaer Polytechnic Institute. I'm majoring in mechanical engineering, and I'm minoring in electrical engineering, and also in economics. So a lot of the main work I do is about, I do a lot of physical prototyping, testing, data collection, and kind of doing some analysis of the results, and taking a very methodical approach at areas of improvement. So this would be new ways, so new designs, improvements on designs, new materials, completely different kind of work, new methods for cleaning, new methods for moving around, new methods for knowing where we are. It's a wide variety of the kind of work that is done in R&D. So it definitely is interesting. Before, when I had the opportunity to actually be in the office, I was doing maybe about a dozen plus different things each week. So there was never really a boring moment, which was nice. I guess kind of my path that brought me here in high school, I assume many of you had something similar. I did first robotics, but I also did set construction for my theater department. So, I've always had I have the cliche answer of always enjoying working with my hands kind of thing. To me, engineering is just another way to say problem solving. So I feel like that's another kind of look at it, is you see something and you want to fix it or make it better. And once I got to RPI, I, kind of went up, I guess, from my high school interest. So starting my freshman year, I got a research position in the robotics department. And my first project was involved a lot of different things. So I was doing some coding. I was crimping and making my own Cat 5e RJ45 shielded cables. I was building my own kind of fixtures. I was doing analysis. This is for a project to use a robotic arm to help with the assembly of wind turbine panels, because these wind turbine blades are, the length of, could be the length of like several football fields. So, and right now they're assembled by hand. So it was a lot of like looking at how can we use robots to help with that. So it was a lot of the work I was doing was aiding in that. And it was a project mainly because RPA is a big research heavy institute, we do get grant money, which Katie had said that you guys have been learning about. So we do get money from there, but we also get money from some other sources. So this is a project that was heavily sponsored by GE and IEEE Global Spec, which is a international electrical engineering organization. And I've had my other main project after that was about creating kind of a robot that helps quadriplegics in their home. So if they need, you can kind of direct it and it would be able to go and you could say like open the fridge and it can move and it has an arm and that would raise and it can open the fridge and grab food and generally aid in the home. And that was, I think, one big thing, just advice I'd been getting over the past 5-6 years as I've been making my journey through high school and through college of, it's not always about creating something that can put a ball into a hole or, and although those could be fun and more easily successful, a lot of times it's about working toward creating something that solves a problem and helps others, even if it's not completely successful in the time frame that you want. Any sort of progress is great. So and can help improve the lives of others. So a lot of your work, although it might not seem like it, is definitely very beneficial and can help others, and it's all a learning experience. And the other main thing I do at school is I'm on our Formula Hybrid car team. So we race a Formula grade car, and I was the powertrain team lead, which was the high voltage electrical and drive line. So yeah, I'd say probably my main advice might be, it doesn't really matter where you go, it matters what you do once you're there, and to make the most of all the opportunities you have at whatever school you go to.
It's so interesting to me, and I am a native Californian, that you guys are all representing schools more what I consider East Coast. So that's great, because we are going to be, we do spend some time talking about colleges and admissions and how to discern the different majors at different universities, that they're not universally the same. So appreciate that. And I also appreciate, Ben, hearing about that you did work in a research lab and now you're in industry, because I know that that's a question that a lot of these students have, is like, do I want to go into research? I mean, they're in high school, so, you know, they have a long time to figure it out, but they might have some questions for you about research versus industry. I want to make sure that we have enough time for everybody. And Paul, if I'm not wrong, you're in England right now. Is that correct?
No, I'm not.
Oh,
I'm
well,
in
you should.
Massachusetts too.
I am.
Although I wouldn't mind.
It's Richard.
If
Yeah.
you want to send
It's
Oh,
me.
Richard.
Yeah.
Well, awesome. So the three of you, there's Paul, Brian, and Richard. Those are the other three that we have not gotten to. Did I miss anybody? No. Who wants to go next? Which one of you wants to go next?
Should we get England out the way?
Let's do it. You guys, you're probably ready for bed.
No, but yes, it's 9:30 in London
Okay.
at the
Thank
moment.
you.
So
Thank you.
my name's Richard Thurbon. I'm obviously the curveball that Lisa puts into these gatherings. So I work as part of the iRobot division based here in Europe. Europe covers around 26 countries, everywhere from the United Kingdom to Sweden, Spain, Italy, Germany, France. Some very, very big markets. EMEA is a very big place with a lot of differences in the countries between them. I'm the supply planning manager for Europe. So I sit within what's called our operations division, so supply chain and operations. And basically within supply chain and operations, it's our job to physically build these wonderful robots that our engineers put together, fabulously intricate. And it's our job to direct our contract manufacturers to mass produce the robots, box, ship, and move them from our hubs in the Far East all over the world. So you can go pretty much anywhere on Earth at the moment, and you'll probably find some sort of iRobot presence, and you'll see our product physically in a store. My background, obviously I'm a little bit older than the interns. So if you like, I majored here in England in computer programming when I first started out. Must admit, I didn't quite know what I wanted to do at that point. Computer programming seemed quite cool, as you can imagine. And then I ended up, one of the pieces of coursework I did for my computer programming degree was designing a pizza delivery shop, and programming and doing the software behind it. I mean, this is 90s programming, trust me guys, it's, you know, it didn't look pretty. But that really got me into the interest of, well, hey, great, you know, we can make a pizza, but how does it get to a customer? How does it, you know, in those days, obviously it was still bikes and cars as it is now. So that got me really interested in the physical sort of movement of goods and also the production of an item. You know, engineering, you're putting something together and then somebody's got to put it together and make it work and give it to somebody else that wants to buy it. So that's pretty much where operations come in. As you can imagine, we're shipping millions of robots every year around the world. You know, EMEA is no exception, as is the Americas. And one interesting bit about iRobot is obviously we have a huge swathe of people, all different disciplines, all different skills. So, you know, I have to work with all manner of different people. You know, even an example today, I've had conversation with an engineer. The next conversation was with the chief commercial officer. The next conversation I had was with marketing. The next one was with sales. So you end up relying on these fabulous sort of iRoboteers that we have around us. You know, nobody has all of the answers. None of us do in the company. So, you know, you get almost the privilege to work with, you know, other people and see all these wonderful things put together. And then you can come along and go, okay, here's my bit. Here's where I fit into this picture. The other thing we always say in operations, and it's probably a good one for you guys as well, is that you should never be afraid to fail. iRobot is very, very proud of the fact that, and I know the engineers will do, you know, they break things on purpose all the time, you know, and that's to make sure that, you know, we understand where things are going to fail. My job, you know, I will never 100% guess how many people will buy a robot in England on Tuesday. You know, I can't be right 100 times, but I can get close, and I can learn from those mistakes. I can learn from where we get it wrong. So, you know, one big thing we always push at iRobot is, you know, do it, fails, do it again, fails, do it again, it works. And that's, you know, something that you should take along. And it's absolutely also right if you don't have the answers. You know, you're not expected to know all of the answers. This is, you know, why we have so many people. And I think it was Erin that said it as well. There is a huge amount of passion in the company behind iRobot. It's really cool stuff. I mean, let's face it, guys. You know, building these sort of robots is great fun, and it's you know, it's a wonderful career to get into. But it's like I said, you know, if you don't know what you want to do now, that's okay. You know, it doesn't stop you working in a robotics company. You know, I'm a testament to that. I worked in makeup at one point, you know, but hey, I'm here. I'm in robotics. So, you know, just don't feel like you need to know everything now and that you won't know everything when you get here. That's the whole point. So there you go.
Oh, thank you. I know one of the questions we keep coming back to in these past weeks is humanities or engineering. You know, there's so much pressure in high school now to know what you want to do and make that decision. So I really appreciate that you talked about that. There's room for all sorts of people, but what you guys are showing is sort of a career path that they're not getting to see at USC, which is a career, you know, more than just research. I like that I'm hearing that people are doing different things all the time, because what a lot of high school students learn when they're in a lab, it's like the same thing over. You're waiting for results and it takes a long time. So, okay, Brian, since Paul's not in London, should we end on him and turn to you next?
I can go. I'm unmuted already. So I'm Brian Doughty. I'm a senior principal mechanical engineer at iRobot. I graduated high school a while ago, but I got into mechanical engineering because I kind of knew early on that I enjoyed building things, tinkering. I was an avid Lego person. I played with Legos far longer than any of my friends did. I have a child now, so I have an excuse to play Legos for hours again as an adult. I was always taking things apart. If it was broken, I would take it apart and screw around with it. Steel motors, steel batteries. If it wasn't broken, I would take it apart and sometimes get in trouble. I was on the robotics team. First wasn't a thing when I was in high school at my school, so I found other opportunities. I went to Northeastern University for mechanical engineering. And I got involved in the first team there. I also got involved a little bit with the Mini Baja team, which was more automotive. They build a rig and race it. So I've looked for opportunities throughout my education to get involved with engineering because I sort of latched onto it pretty early. I found out in like 6th and 7th grade that the science classes were my favorite ones, and building the bridges out of straws and paper clips was like the most fun I ever had at school. And so the sort of how can you build something within requirements that has to do something had always been interesting to me, and so that's how I sort of knew to get into it. I found out at Northeastern that there's different types of mechanical engineers. There's the ones that spend a lot of time behind a computer doing analysis, running in a lab. And then there's the type that are more on the forward side of things, doing product development. So I learned pretty quickly at school that I wanted to focus on being a product developer and not, an analysis mechanical engineer. So I did a bunch of co-ops. So Northeastern, I did 3 co-ops. I got lots of different exposure. I did a stint at a medical company. I worked for UMass General. And then my last one was for a consumer product company that made guitar amplifiers. And so that was a great opportunity to learn about doing product development. So now I'm at iRobot continuing to do product development. I'm in one of the advanced development groups. And so we are essentially looking at what's the future of iRobot. We'll have, we have these program managers and they're given a product that they have to release on a schedule. And so one of the things that when you're doing a new product like this, you try to do is remove risk from your build. And so if there's lots of things that no one knows how they're going to work, people get nervous. And so an example would be, and this isn't something we're doing, but if you wanted to clean a bathtub, how would you go about doing it, right? And so our group would look at that problem and say, well, if you're going to clean a bathtub, have to figure out how to clean the bottom of it, and then we should probably clean the sides as well, and that part in between that's curvy, that's going to be tricky, and bathtubs have different radiuses and different corners, and so that's a problem that our group would take upon and really try to solve. And so how are we going to drive around on the floor? How are we going to stick to the side of the wall? How are we going to get there? What are we going to use to clean it? And then because this is a product for a consumer, the question is it going to do the job they want? How are they going to interact with it? Will they use it? Will it piss them off? Will they stick it in the corner? Will they tell their friends it's the greatest thing they've ever had? Is it dangerous to them? And so these are all questions we're sort of keeping in the back of our mind as we're problem solving these. And so one of the things that's interesting around engineering is that there's sort of always opportunities to learn about the product, learn about the technology, learn about how consumers think about the product. And so it's been particularly interesting for me just because there's always something new on the horizon that you can go and chase.
Fantastic. I have an idea. I think iRobot should deliver pizzas and take advantage of Richard's original interest. Okay, you heard it here. Do I get stock? Do I get stock?
We can't talk about
that. Okay, great. I definitely want to make sure that the students have some opportunities to ask questions because each one of you is bringing up a different facet that's really interesting. And one thing I notice is you guys all use the term co-op, which we don't use at USC. And I'm assuming it's like a semester. It's more than a semester. It's kind of an internship where you get to work for a company.
It was 6 months when I was doing it, yeah. So it's a little longer. It gives you more of an opportunity to be embedded because at the end of 3 months, it sometimes feels like you're just getting the swing of things and just getting to do the fun work because you're just building that trust that you need to build for people to give you the cool stuff.
Great. Okay. Now I'm learning stuff. Okay, Paul, can you wind us up, and then we're gonna hope that people will ask questions. And Brenda asked one too. Well, let's let Paul talk, and then we'll go to Brenda's question.
So I'm Paul Angelosanto. I am a user test specialist. Does anyone know what that is? No, iRobot is not answer. Please don't answer. No? I kind of didn't think anyone would know what it is, but I just thought I'd throw that out there because I had no idea what the position was when I got offered it. And that's part of what's exciting about being flexible with your career. I started off, I did work at hotels and convention centers, like setting up things for meetings and presentations. And that led me into an interest in computers, which led me into a career in tech support, which led me to a career in a training, which suddenly led me here. So I want to echo a lot of what Richard said, and don't be afraid to be flexible or think that just because you learn one thing, it's going to limit you to something else, because I had no idea that training would come in handy here, but it does. And I had no idea learning the skills of just being ultra polite and working in the hotel and convention center industry would apply here. But like Richard said, I have to work with, like today I worked with a VP of the company. I also worked with some interns. I've worked in people engineering. You just got to be able to speak at all different levels and learn how to just interact with people. And so all that stuff really just kind of comes in handy. And it doesn't matter if you feel like, oh, well, I'm just going to go and I'm going to learn this one thing and this is where I'm going to stay. That doesn't really block you into that. You could go somewhere else. And I'm just going to drop off really quickly with that, just because I do want to leave time for questions. And we're shockingly taking a long time. So.
You're muted, Katie.
Yeah, we're lucky that we have so many of you here to talk. We're not used to getting so many engineers together. So we really appreciate you being here. Brenda did ask a question. Brenda, we could see it, but why don't you unmute and ask it and have a voice?
Well, I just wanted to ask, what is the difference between user research and then UX and UI design?
That's an excellent question. And I actually was working with UX yesterday. It's actually very similar. UX is more focused on the user perceptions, I would say, and that whole end of it. Where I'm kind of focused is more, okay, this product is already pretty well done, but does it actually do what the engineers expect it to? So like, let's say where my job kind of falls is, let's say Brian invents a new robot today, like he invents his bathtub robot. Brian tests it out in labs. It works great there. That's fine. But then we got to go outside the labs and test it. And that's where I would come in, because Brian has his whole job to do. He can't be running a test outside and dealing with a whole bunch of people at the same time. And that's kind of where the difference falls between the two departments.
To expand upon that, the user experience team that we have would actually be involved very early with the development effort. And so they might even be the ones that decide, hey, we should look at a bathtub robot, because they're out there talking to the customers, understanding what it is they need, what are the pain points around having a dirty bathtub, how often do they have to clean it, what level of satisfaction do they require, is the level of satisfaction for cleanliness the same if a robot does it? Maybe they don't care if it's perfect because they didn't have to do it in the first place. And so they're helping answer a lot of the expectations of the customer, so that when we go to build our thing, we know we're solving the right problems and we're not just making a paperweight that they're never going to use.
Okay, yes, that's really cool. Thank you.
Yeah.
I wanted to ask specifically, like, how have the further like R&D pivots from to like software affected you guys in the hardware department?
I can take that, I guess. So yeah, iRobot, I've been there a while. It started off very hardware heavy. A lot of the robots we were building were pretty simple software machines. As technologies progress, they have more and more requirements from a software point of view. So if we're started with cameras, and then apps, and then smart home integration, and now Alexa, go clean my kitchen. And there's some other crazy stuff coming out at some point. But it's definitely pivoted. And so we've recently started to focus on and growing the software team, because what we're finding is that we have the ability to develop hardware faster than we can develop the software for it. And so we were getting to the point where the product from a hardware standpoint is ready to ship, but the software is not there yet. And so keeping those two teams in balance has been a bit of a challenge, as iRobot has both grown in sales and size, but also in its need to have software in tandem with hardware.
Would you say that's like changed more rapidly over like COVID?
Our use of IT infrastructure has changed more rapidly since over COVID. I don't think, sorry, someone's making my system ring here. I don't think specifically that COVID has had a huge impact. I don't know where.
Okay. Thanks.
I have a question. I wanted to know why you guys chose industry over research. And I noticed that a lot of you said that there's a lot of problem solving in industry. So I wanted to ask if you guys have like any specific obstacles you remember that were difficult to overcome in industry.
Ask it one more time. I was dealing with an incoming phone call on my computer. I couldn't hear you.
Yeah. Okay, it's okay. So my question is, why did you guys choose industry over research? And I noticed that a lot of you guys said that industry has a lot of problem solving in it. So I was wondering if you guys had any specific moments where you had like a large obstacle you had to overcome in industry.
So I can speak on the second half of that more than the first half. This is actually my first internship that I've had in industry. I haven't really done any research before, and this is my first electrical engineering job that I've had. But a lot of my job is figuring out when something is going wrong and being able to document that and try to explain why something's going wrong and try to assist teams in being able to fix that bug in the future. But recently I was having an issue where I was given a product to work on, and I realized that I needed to insert some test points so that I could get some data. And while I was attempting to take this product apart in my home and solder these points on, I ended up doing something bad to the product. I don't know what happened. Something went wrong in the reassembly process. I had pieces everywhere. It was a mess. But luckily I was able to get some people over Zoom calls to help me figure out what was wrong. But that was a big obstacle I had to deal with. Was, first of all, it's difficult enough to debug something in person. It's even more difficult when you just have people slacking you or like on a phone call a state away. But after some very frustrating hours, I got it back to be working again. So yeah, it's just, you have to reach out to people a lot to get questions answered too, which I think is really important, especially as an intern, but also just as an engineer in general. I think Richard was talking about this earlier, where it's a really collaborative thing where you have to reach out to people of different backgrounds all the time to get questions answered and exchange information. So
Yeah, I'd like to comment on what Erin said. I totally agree. One of the things that I've learned is to not be afraid to reach out to people. I was working with the VP this morning. I solved a problem she had with her robot, but honestly, I have no idea how I solved it. So what I'm trying to do now is work with some other people to figure out, why did what I do solve this problem? So yeah, don't be afraid to reach out to people, like Erin was saying.
I can just talk. So between research and industry, at least for me, in my opinion, there's something a alluring and exciting about building a product that you know is going to go on a shelf and go into someone's home, that you're having an impact on their life in some way. If you weren't having an impact, they wouldn't buy it, right? So provided that you're in a company where you're selling product, it's exciting to know that what you're doing is going to bring a smile to someone's face, or let their grandma have a clean floor, things like that. And again, in industry, there's also a little bit different, especially with a company like iRobot. So we're a market leader. There's sort of this ever-present battle to maintain that status and keep competitors at bay. And so there's certainly some excitement and exuberance that comes along with that, where sometimes things are totally crazy, and chaotic, but there's sort of excitement within that, and knowing that you're sort of never going to have a dull day. There's always excitement to be found somewhere. And so I can be guaranteed that there won't be a day where I, before COVID, would go and sit at my desk and just hack at my keyboard for 8 hours. There's always going to be something to break up the day and bring me a surprise.
Yeah, I think in industry as well, the important bit is never be afraid to ask questions of people. We do this all the time at iRobot. Whenever I visit the Bedford office, I'm just usually wandering around just asking, hey guys, what's that? Or, what are you guys up to? Never be afraid to ask questions in industry, because hey, you'll find something new. You'll find an answer to something, but actually you'll find something really cool that will, set you off on a whole new path as well.
Another thing about industry, so prior to iRobot, I was at a startup. And so if you're kind of unsure around what you want to do, if you happen to have the opportunity to work for a startup, it's wild and crazy, and you kind of hang on for dear life. But because of how they are, especially if you join a small one, the opportunity to do, to Lauren's point, like you can do anything, or you can do everything, or that was sort of the case here. And so I was writing instruction manuals, I was answering emails, I was following the forums to see how people were writing about our products. I built a manufacturing line, I designed 3D parts, I was a sales guy trying to get distributors online. And so in the course of 2 years, I did like 11 jobs. And so I'm still a mechanical engineer. However, it gave me a massive amount of insight into how other people have to do their job. And it gave me empathy to work really well with those groups, so that I know that I can't ship a product without having someone generate instructions and write copy. And that I know that marketing has to hire an artist to do any ads they want to do. And there's all these intricacies that I would have never known before. So if you kind of want to get a shotgun approach at learning lots of different jobs, that can be a great opportunity.
The other thing about kind of the difference between industry and research, I've only had limited experience with both, but especially research and it definitely depends a lot upon the field and what the company might be. But I feel like with a lot of research, you might be more in a lab and doing repetitive work, and kind of long hours. Not that we don't have long hours in industry, but and not that we're all not stuck inside right now either, but I feel like there's a bit more going on. It definitely does depend upon the field. And besides working at iRobot, my previous work experience I've had was at another firm when I was younger, and I did mainly just CAD work for them. So for those who aren't familiar, it's 3D design and part modeling and whatnot. So that was just me sitting on a computer. So there are mixes to what it might be, but I given that I had a bit of the experience in the research field at my school, I wanted to try a lot of, like I said earlier, trying a lot of the opportunities I have available to me. So I wanted to get some experience in the industry, because there's also many different types of industry. We're an example of the consumer product industry, but there's a lot of defense, and there's a lot of you could be working at a company that makes the microchips. You could work at a company that makes the machines that makes the microchips. You could be working at so you have a lot of different kind of areas of industry here. So we're just one example of one type of industry.
I think you are all bringing up an interesting point that I want to make sure to touch on too. I I've worked at a startup. I was a product manager at a Fortune 500 company, and I'm an ex-professor researcher, but in the humanities, not in engineering. Um, and my husband's a serial entrepreneur, which gets tiresome. I will let you all know. So some of us have some strong financial responsibilities to our families. And I would like to hear about industry versus research that way. In some ways, to be able to graduate with a degree in engineering and be able to walk into a job might be really important to some of the people in our cohort. And the types of money that you might make in research versus industry. And I've got some undergraduates who are my helpers here, who are doing robotics, who might want to know about how to get an internship. I might also have a PhD student in robotics who's wondering industry, research. So can we talk, just touch a little bit on finding jobs in industry? How far can you go with a bachelor's degree in engineering in industry? And let's just touch on that financial aspect just a little bit, please.
So I have a bachelor's degree. I didn't go for an advanced degree, primarily because I wanted to get in industry and get experience. I discovered rather that in the product design world, where you're developing consumer products, developing something, that experience and exposure was more important than academic value, at least from what I discovered. So it was better that I had experience doing injection molding design for some knobs or switches or whatever it was than I had an advanced degree in robotics. It depends heavily on your industry though. So if you're going to do research, advanced degrees are a pretty big thing. If you want to do aerospace, they're really important. So really you should research what it is you think you want to be doing. And, not if you're in high school, but as you get there, understand what your limitations will be. So like I knew that I probably wasn't going to go into aerospace anytime soon, but that wasn't a desire of mine anyway. And so I sort of right-sized my career, and in getting in the door and moving, I was able to build my experience, my reputation, and my salary faster than many of my friends that went for advanced degrees, because they just didn't have the experience I had when they, got their second master's. I had 8 years experience and I could land a job they couldn't. But it's unique to your situation too. So don't say, I'm not telling you don't get one.
So a lot of schools have a program where for an additional year, you can also get a master's. And so I'm, normally when you go for, at least in kind of, I know engineering fields, when you're going for a master's or a doctorate, you normally apply and it's usually then free if you get in and you don't have to pay for it. So, but if you do this, you are paying tuition, but it's only 1 year of your life now instead of 2 years of your life later. So I did that program because it's only going to be an additional year and I'm going to be getting my master's of engineering, mechanical engineering, because I thought if I decided later I want to go back, I would rather do 1 year now than 2 years later. And I don't have to take like the GRE or anything like that. So, yeah.
Regarding, how to get an internship and how to kind of break into the industry. I'm actually going to school as an electrical engineer, but I have a focus in audio engineering. So originally when I was looking for jobs, I was looking more at audio engineering positions, places like Bose and Yamaha and stuff like that. But I really put myself out there and went a little outside of my comfort zone and started applying to places that fed into my coding background. I know 4 or 5 different languages. So I started looking at more software positions and I started looking at robotics and stuff like that, to really just, throw a wide net. And I think that really helped a lot because iRobot is not somewhere where I originally thought that I would work at. It's not something that I was really thinking about originally, but I'm really glad that I'm here because it's taught me a lot of interesting things that I was not, that, you can't learn in classes. And also just, I'm learning a lot more about robotics that I didn't have a super large background on. So I'd say, cast a wide net. Don't be afraid to put yourself out there. I was a little uncomfortable when I first arrived at iRobot. I was afraid I wouldn't, fit in right, or I would not know as much as I'm supposed to. But yeah, I don't know. I guess that's all I have to say about that.
Yeah, I would definitely agree with just like sending, for me at least, like sending out as many applications to whatever companies that like seem like they could be interesting. Because I know a lot of companies just receive so many applications for just one position. It's better to not put all the eggs in one basket, as they say. And then as far as graduate school, the robotics professor, one respected robotics professor at my school would always say, graduate school is for closing doors. It's not for figuring out, I guess, what you want to look at or what you want to do, but it's when you know what you want to do and you want to go further into that. Whereas like in industry, I get to do more things differently. Yeah.
One other thing to add on to what Brian and Erin touched earlier is definitely, when you're at school, take advantage, like I said earlier, take advantage of the other things you have there. You'll have a lot of clubs and other activities that will supplement your education, anything that might be better than your education, in terms of helping you both get a job and be prepared for the workplace. So I feel like what I've gained from my work on the car team as well as my research is much more beneficial to the work I'm doing here at iRobot than anything I learned in any of the classes, which, I don't know if that's necessarily a good or bad thing, but I feel like a lot of the work of working in multidisciplinary teams and with others and having to do things such as like some writing and communications and following rules and different kind of, limits that you have. I got a lot of experience with that from the car team. And then the having to do every single kind of task under the sun I got is very similar to the work that I had to do for research. So, I'm not sitting here doing bending moment diagrams like I've learned in my classes. Instead, I'm working a lot more with my hands. And although the classes will definitely teach you to be able to think a lot more like an engineer and be able to tackle a problem in a certain way, a lot of the gut feeling or the actual hands-on experience you'll get from the things you do outside of your class.
Just to build on that, so I was hiring interns at iRobot for a while. I was hiring associate engineers for a while. And so things that jump out of the page when you're looking at these candidates isn't a high GPA in the standard engineering classes. Lots of resumes come across like that. It's I developed an electric drive system for a Formula One car and I led that team, or I built the code for the first robot, or I wrote the strategy for the game in the first robotics that brought us to the championship, or, these things where that demonstrate that, you can apply the skills that you learn in class in a real world application. It demonstrates that people can, in general, get along with you enough for you to be successful on something you were trying to do. And so it showcases that, like, you've got a good work ethic. It demonstrates that you can take what you've learned in class and apply it to a real world thing. So yeah, to mirror that, like, definitely look for opportunities to, at least, for engineering or for whatever it is you want to do, show your passion on the page. And you can do that. You won't do that by having a high GPA. That means you can study and be dedicated and focused, and it's not unimportant, but it doesn't necessarily help distinguish you from the other people that can do the same thing.
On top of that, I found also networking with other people in your college is very helpful when you're getting a job, because like if they've had an internship somewhere, like maybe they can recommend you, or if they're becoming full-time somewhere, it's nice to have an in with someone to get your resume a little further along.
Yeah.
Another thing with that is definitely have a LinkedIn. Like once you go to college, you'll want one. And one thing I did when I was looking for the position I have now, back before I got this one, was I was just messaging people I didn't know on LinkedIn, but people who were graduates of RPI, the school I go to now. A lot of them, of course, didn't reply, but some of them did. And some of them, then because that way I actually passed my information along, because it's very easy to get lost in the cloud. There's lots of companies who have systems that will scan resumes and scan cover letters and will automatically throw you out. So it's really good if you can use certain tactics to get around that. Some of those are by using keywords that they have in the position you're applying for in your resume and in your cover letter, but others are by going through contacts and networking and working around the normal
So
channels.
doing like a blog or having a web page, if you're passionate about stuff, is useful as well. You can link to it on LinkedIn. You can put it on your website. And so, saying you did a solar car project on your website and led the team is one thing, but then having a link to a 5-minute YouTube video where you do a walkthrough, or a paper you published, or pictures of the 37 quilts you made because quilting is your thing, right? Just demonstrate passion and that you can care about something. And again, anything you can use to demonstrate that you're different than the last person's resume they looked at.
Yeah, I'd definitely say during the interview process that I went through before I decided to take this position at iRobot, the most questions I got on my resume were people asking about like my welding experience that I got because of a job that I have at school. I had to learn how to weld for that position. I had a lot of people asking me about that and like, what am I doing welding? What's that about? And then I also got a lot of questions about the clubs that I'm in. And I'm not in industry clubs at school. I'm in a knitting club and I'm in a coffee club. But people just like to hear about the things that you're passionate about and the things that you like. So adding stuff like that, is useful and shows that you care about other things. Yeah.
Well, I'd like to jump in and say, this is so great. This Friday, we are beginning to talk about storytelling and how do you share not only the results that you're getting in the lab, but how do you talk about yourself and your qualities and the values and what you bring to a team, whether that's to a college application or something. We are also encouraging the students to develop their LinkedIn profiles, to put what they're doing in Shine on their LinkedIn profile. And we will be doing some taped stories later. So you guys set it up for me perfectly. And I'm wondering if anybody wants to link in with you, if you would be open to linking in with a high school student. I'll just put, you don't have to answer. And I would have to agree. I mean, part of what Shine is it's experiential learning through experience. And I would like to encourage the Shine students to hear this advice about networking and network with each other more and network with me more. I have office hours every week. And I love to see the same people come again, but if you haven't come to my office hours yet, you should come. Now, I want to be mindful of your time because poor Richard, it's like 10 o'clock after 10 now. You're welcome to stay as long as you want, but I told Lisa an hour and we're already at an hour and 6 minutes. So I want to put it out there. First, I'll say to my Shine students, any last quick questions? Because if you link in with these people, you can ask them again. And I want to ask all of the panelists from iRobot, do you have any last things you'd like to say or last questions for our cohort to think about that maybe they don't answer you now, but to think about? So I'll throw it out to you for a last word.
So you can go first if you want.
I'll say, don't be discouraged. Some things are hard. And so, you will find success by persevering. And so, if you really want something, push, keep pushing. Don't let people get you down. Don't get disheartened. The sun will come out tomorrow, but do keep trying.
So I have two last things. I know I keep kind of jumping in, but one of them is earlier Katie had mentioned about how people can really choose, what do they do when they have the choice of humanities versus, science. But I feel like you don't have to choose. I feel like they can definitely be integrated. A lot of people know there's a strong correlation between math and music. People who are skilled at both, you can really enhance a lot of your other education. And anywhere you go, whether it's research or industry, you're going to want to be able to communicate and write with others. And a big part of communication isn't actually speaking, but it's listening. So being able to really understand and convey your thoughts back. and going to a school that allows you to take a lot of other classes and things that interest you. There are some schools that when you go into a certain field, they're very restricted, but there are others that will allow you to kind of, if you're interested in this, you can take that class. That's what I did at RPA with economics. I took a few classes, was very interested. So I was like, well, I'm only one class away from the minor, might as well just do that. So, you know, it allows you to kind of, you know, do a little bit of this, do a little bit of that. You know, we'll see how the fall goes, but I'm supposed to be taking a drawing class in the fall. So, you know, there are all these other things. And then the last thing is about with the networking. Once you get to school, and if let's say you want to get involved with research at whatever school you're at, and you know of a professor who does something in a lab that you're really interested in being a part of, but you don't know the professor, you don't really have them, I think kind of what Kay was saying about going to office hours or just going to them is a great idea. You just go there, you knock on the door, introduce yourselves, you know, talk to them, make pleasant conversation, and you know, and they'll remember you. And you know, do that over time, and then you kind of develop a connection, and then you kind of mention that you're looking, you know, to aid them, or you're really interested in their work, ask them about their work. It's all about making those kind of personal connections that will really help you get places.
I would also like to quickly say, oh, sorry, Erin, I didn't mean to cut you off. It just.
No, it's okay. I just wanted to really quickly say to any women who are going into STEM to also, you know, don't be afraid to stand up for yourself. Don't be afraid to be confident about the field you're going into, and don't be afraid to take up space, because you are valid and important, and you have important things to say. That's all I wanted to say.
Yeah, and I just quickly wanted to say to echo what Richard said earlier, don't be afraid to fail. If you think, hey, I'm probably not going to be able to do this, but I really like to try, just try it. If it doesn't work out, you can learn a lot from that failure and just move on to the next thing.
Yeah. Upon reflecting on things, people often find that their greatest accomplishments coincide with their greatest challenges.
I think I'd add in as well is that, you know, the most obvious route that you guys think, oh, you know, to get into a robotics company, for example, it's not always the right route. I work in robotics. I'm proud of the fact I work in robotics. Do I know anything about engineering? Probably not. But I'm here, and I get to work and learn with people, you know, about engineering, about marketing, about sales. So, you know, having that interlink and that rapport and talking to other people in the company, that, you know, it doesn't matter that I'm not an engineer, I haven't got an engineering background. You know, I fully love and enjoy, you know, engineering. You know, I'm always bugging our engineers in London about different things. You know, I'm usually tripping over a robot in the kitchen or something, and, you know, oh, what's this? You know, and but that's the beauty of it. You know, and it's like I say, you know, don't be scared that you think, oh my goodness, I've got to major in, you know, this engineering degree to get into this engineering industry. Not at all. You'll find iRobot is kind of littered, like Paul. You know, you're littered with people that started out doing one thing, and then all of a sudden, you know, a chance conversation, tripping over a robot, and suddenly you're doing something completely different that you end up doing and enjoying for the rest of your life. So, you know, don't think the first route is the most obvious one.
Well, I think this is so fantastic. It's really been fun for me to hear all of your views and advice, and I totally agree with everything that you're saying. So being mindful of your time, I want to say to my Shine students, please help me in thanking them for taking time out of their busy days and giving us these insights. And I'll stay on a little bit if anybody else wants to stay on. If you need to go back to your work and stuff, or I think that a lot of my students have to go back to their labs or to their remote ties to their labs. So I'm glad to see people thanking you in the chat too. So thank you so much. We really value this perspective that you're bringing to us.
Take care, guys. Good luck.
Thank you very much.